this portion of our training film, we're going to go into inductive tracing. And this is going to be a way to locate and trace out a cable when you physically cannot gain access to it. But before you see this portion of the tape, since we are going to deal with the application of the instrument, you really should make sure that you've understood the first portion of the tape to the degree where you're comfortable with it. And now that you've done that, let's move on to inductive tracing. Again, this is an inductive antenna. Inductive tracing in the instruction manual tells you to place the transmitter over a known locate and in line with it, and we can loop signal into the ground, and it'll go into that utility and place tone on it, and then you can trace it. And that's easy to say, but I think before we really ended at that point, we probably ought to go in and talk about what the inductive antenna is really trying to do, because I think we can help you in maybe making some locates that you're not able to make right now. This inductive antenna, it's going to be this shape regardless of who is the manufacturer. Now, it may be buried inside of a blue box like our Model A6 tracer over here, the antenna is, or it may be buried in a yellow or an orange or some other kind of a box, but the physical shape is kind of like the transmitter we had here. Back in our first segment of the film, we said that a transmitter could only generate a wave, and that's all it knew how to do. And a receiver could only pick up that radio wave. This is back in part of the transmitter. The radio wave is being developed, only it's going to leave the transmitter in a little different way. If we could envision this, I'm going to use this picture window type antenna here because I believe it will be easier to see what we're trying to produce. If we envision a hula hoop or a radio signal leaving the center of this picture frame, going down and around and coming back up in the other side, back in the window in the same point that it left off. So there becomes this hula hoop that's running around and coming back up. There's also one that's going to go up and around and down, and there's one that's going to come at you and back in. In fact, they go in all directions. It's kind of like a donut or a tire, if you could envision that, with radio signals going all directions. Well, I'm going to superimpose this antenna now on our drawing and making it look right here, because just like this, we're going to bring the cable over and we're going to put our transmitter right here. But there's actually a radio wave that comes out of the center of the antenna right here, and it goes down around that cable right there and back up the other side and comes back in the wind. And there's one that's going to come up and around this way, and there's one that's coming out in that angle. The one that's going this direction is the one that I want to talk about. And this is what we call open air link. Now, with the Aqua-Tronics equipment, we tell you on low power to be 20 feet from this antenna before you start making a trace. And this is why. Because if you get closer than 20 feet, we're placing tone on that cable right there, and that tone is going to come above ground for your receiver to pick up. But if you get closer than 20 feet distance to this transmitting antenna, what you're going to do is pick up this radio wave here instead of this radio wave here. Or in fact, you pick up your transmitter. Now this signal is falling up very strong here and it's falling off. But after 20 feet, the signal is very, very weak, and so now you can work and try to pick up this signal right here. So with inductive tracing with Aqua-Tronics, you must be 20 feet from this antenna before you start locating with your receiver. If you have some other manufacturer than Aqua-Tronics, then certainly you want to address the instruction manual to see what that distance would be. Here we have a picture of two cables in the ground, and with the antenna setting right here. Now remember, the instruction manual told you to place the transmitting antenna over a known locate, and it'll induce signal into the line. It says over and in line with it. So I've set down this transmitting antenna right here, and the hula hoop is coming around this way, and that's this lower one. There's one that goes up this way, and there's one that comes at you too, but we can ignore that now because we're going to be out here 30 feet away locating, and so we're over that 20-foot margin. The important thing is to see the antenna is setting in that direction. Now, I'm going to call, this being our transmitter right here, our transmitting antenna. Notice we've got the loop going down and the one going up. And I'm going to call this cable A, and I'm going to call this cable B. And now I want to give you a few minutes to really study this program, or this picture right here. And I want you to tell me, are we inducing tone into A only? Are we putting it into B only? Are we putting it into A and B? So how many of you, and be honest with us now, how many of you think tone is only being injected into cable A? And that's a cable that's running this direction. B is a cable that's running 90 degrees from it, and they're not touching each other. But it is being linked there. How many of you think tone is in B only? Now, how many of you think it's in A and B? Those of you that guessed A only are correct. Remember back when we drew a picture here, and this goes back in the first segment that we did, we said when we bring an antenna in and we place copper wire right there to where the field pattern links that conductor twice. It goes into it and it exits on the same angle that it went in. We produced a null reading, didn't we? What is a null reading? A null reading is a loss of tone in that conductor or that antenna. The same principle exists here. We have the tone being radiated, entering the conductor that's running this direction, and then it's exiting in the same angle. So tone is really only in cable A. If we wanted to locate cable B, we would have to turn the antenna this way. Then we would be linking signal into A twice and we would not be able to locate it. So the same theory applies whether it be a receiving antenna or a transmitting antenna. Here we have a pole, and this is going to be a transformer. We want to trace that cable from pole to transformer, and we're going to start out maybe with one method, but this is going to be a very, very long trace. In fact, the trace is going to be beyond the ability of a conductive trace. Here I could get at the cable, and so I applied tone directly to it, like a primary. I put tone on the neutral, and I was only able to trace the cable down to about that far because of the physical length of it. In fact, let's take it about that far right there. And right about that point, the signal broke up so bad that I really couldn't be sure of my signal any farther. And of course, I could put tone on at the transformer, and I could work back a ways, but I'm still going to have that area in the center because of the physical length that I can't really get at the cable. So at this point, we're going to do what we call leapfrogging with our inductive antenna. When we can do this, in fact, as soon as we're finished with this, we're going to show you another way of using an inductive antenna for locating an unknown spot. And we could use that method for locating this spot, but let's just put conductively right there, and we get out to that point, we've lost our signal. Always, with the Aqua-Tronics, from that point where signal breaks up, always move back the 20 feet. Remember, on inductive tracing, we said we wanted to be 20 feet from that transmitting antenna with our receiver before we start locating. So from that last good locate point, move back 20 feet and set your transmitting antenna right there for an inductive trace. And there's a very good reason for moving back 20 feet. The reason is you don't want to lose sight of your cable. So now, since my transmitting antenna is here, I can move down 20 feet, pick up the cable at the last known mark, and I can trace again. And I'm going to go out, and it died. Okay? So now I'm going to back up 20 feet and move this antenna now to that spot. Then I can move out here, that 20 feet again, and pick up my cable, and I can make that turn. Had I not been backing up 20 feet, had I moved my antenna, this transmitting antenna, to that spot and wandered out here 20 feet away and got lucky, and I run out of signal right away, and then I move my antenna to that spot, I'm going to wander out here, and I could wander out there all day long looking for a cable that doesn't exist. Why? The cable made a turn on me. And so you'll make these turns if you'll back your antenna up the 20 feet from your last known locate, so that when you take your receiver out there, you're not losing or leaving a gap of cable that goes undetected. Too easy to get lost with a cable making a turn, and then you spend too much time out here looking for something that's not there. As we said earlier, the instruction manual told you to place a transmitting antenna down over a known locate and carry the receiver to make that locate. We don't always know where a known locate is. Good example. Here we have a street light. We've got another street light. We've got another street light. This could be a transformer and a pole. It could be it could be a meter and a transformer. But this is out in the parking lot where I've got street lights and I'm trying to locate them. We're going to do something different than what the instruction manual told us to do. The manual says set the transmitting antenna down, carry the receiver. We're going to reverse that. We're going to carry the transmitting antenna and set the receiver down. But the first thing I want to do is take my transmitting antenna out about 30 feet away. And I'm going to set it down right there in this spot right here. And I'm going to aim the end of the antenna right here, aim this antenna right at that pole. So I line it up and I set it on the ground and show that. Once I've set my transmitting antenna down, again, 30 feet away, I'm going to move in and I'm going to position my receiver right there. The transmitter, by the way, when you set it down, turn it on, because now that we're down here with the receiver, we want to turn the gain up a little bit, maybe even to where we hear it sputtering from signal, open air, link it. Then I leave my receiver at that point, leaning against that pole, and then we're going to move the transmitter around, always keeping the end. As I walk a circle around this pole, I'm always going to keep this end pointing at the receiver or at the pole. So notice we're moving right here. Notice we're moving here. As we come out here, we're always aiming at that pole. Now, the ear is a very poor device to tell amplitude. Somewhere in this area right here, you're going to hear your receiver turn on. Don't worry about listening for what's the loudest tone. Just mark the ground, as we've done right there, and keep walking. Somewhere out in this area, the receiver is going to fall down or die. Having done that, mark the ground again. Out here, there would be nothing. You've got you can divide by 2 and get pretty close. And we're going to show this on the outside portion of this part of the film. But we can divide by 2 and put our transmitting antenna right there. We can walk back, maintain this 30 feet. Very important to keep this uniform distance. Walk back, turn your receiver down to where you can just barely pick up the tone. Any less signal and you'd not be able to pick it up. Now, if I moved that direction, I'd lose tone right there because my gain's turned way down. Then if I walked this direction, I'd lose it right there. Now dividing by 2, I can get a lot closer. Now I've got a starting point, because before I didn't know where the cable is. Now I do. In other words, by carrying the transmitting antenna and using the receiver at a local spot or setting the receiver at a local spot, I was able to determine where that cable was. Now I can pick my receiver up and locate that line. I can move here, but watch your 20 foot. You must not get closer than 20 feet between that point of using the receiver and that transmitting antenna. Now, once I end, I could take that transmitting antenna and move it over here, and then I could close that area out so I could literally make my locate. Now, if a person knows what they're doing and they know the direction of these antennas, Two people could also use this instrument. Since this is in the peak mode, when you're standing over and in line with the cable. Remember we talked about back early in nulls and peaks that if you stood crossways to a cable, you wouldn't locate it. In the peak mode, you must be in the null mode, you can be at any angle as you go through the locate. But in the peak mode, you must be at 90 degrees from the route of the cable. All right? This would be a peak mode if a cable was running this direction. So let's take a bird's eye view. And if we had a cable running right there, I could set my receiver in this mode or put the antenna in that direction. And since the antenna is going to be over and in line with it, some 30 feet away, I could put my transmitting antenna in that angle. So here I've got my receiver there. Here we've got the transmitting antenna this way. And literally, both of us could walk across the street. So if both of us were 30 feet apart and we were walking across the street, when the transmitting antenna started to get close to the line that we were looking for in the street, my receiver would start responding. I could stop with the receiver and watch the meter. I could just put the meter down on the ground and then continue to motion you with the finger that direction, and then I could back you up because I could literally watch my meter for maximum signal indications and not only position you directly over the cable, but I could put you in line with it also. And now I'd like to step back and have this board erased and go back to the picture that we saw just before here where we've in fact had a pole and a transformer, and I indicated that I would be able to show you how to locate that without making physical contact with it. Let's do that. Okay. This is that same picture we said we'd come back to that's got the pole and the transformer. If we had got out there by ourselves and the conduit was too close to the pole for an inductive coupler, we couldn't get it physically at this, and we're by ourselves, so we couldn't open up a transformer enclosure. So we physically had no way to make a conductive trace. This is where we actually put a conductive trace on or inductive coupler and then went to leapfrogging with our inductive antenna. We need some way of making access to get tone starting out. This could have been done this way of using inductive tracing where we could have gone out here and set the antenna 30 feet away, put the receiver up against the pole, and then walked, always keeping the antenna pointing at the pole and maintaining this 30 feet, because about right there, that receiver would have turned on. And we could have done the same thing in pre-locating this cable by carrying the transmitter, setting the receiver down. Or we could have done it around here. The only thing that you want to watch for if you use this method on a transformer is that some transformer enclosures are large enough that if you are unsure of where that cable entry is in the general area, you may set your receiver down over here instead of over here. This distance could be far enough away from the cable to where you might have trouble picking it up signal when your transmitting antenna put signal on the line out here. So you want to be very careful when you're doing this around a transformer. The last thing that we should make mention is that this radio field that the transmitting antenna is producing is very non-selective. If you have a rebar in the ground, it's going to put tone on the rebar. If there's a gas pipe and a water pipe in the area, it's going to put tone on the gas pipe and the water pipe, providing it's running the same direction. Because remember, we said if the signal links it twice, it won't put tone on it. It must be over and in line with it. And that would include the cyclone fence or the bridge abutment, the steel girders in the bridge abutment. Very, very non-selective tone, like conductive tracing. It's looking for a conductor in the ground, and any conductor that gets in its way, it will pick up on, and then your receiver really doesn't know where north and south is. It doesn't know where the transmitter is. It only knows radio signal coming up from below ground. Let's go outside now and actually use the instrument in this inductive tracing and actually make a couple of locates on some cable and see if this method won't maybe make another way that you can use your locator. We're here at this job site to show you that method of inductive tracing that we talked about on the blackboard. The instruction manual told you to set the inductive antenna down over a known locate and carry the receiver. On this job site, the conduit's so close to the pole we couldn't use an inductive coupler, and we have some plastic involved, so we can't go direct output. So we're going to show you that other method of inductive tracing. And this is where we set the receiver down at the known locate and carry the transmitter. First thing we do is we turn our transmitter on, and that's important. And we want to be about 30 feet away from the place where we're going to set our receiver. And we want to aim this antenna directly at that pole or conduit. And set to inductive, I turn the transmitter on. Then I'm going to turn the receiver on and go lean it up against that pole. And I want to set the receiver at about a high enough gain to where it just starts to pick up a little static. Right, now I have the receiver set up against that conduit. I'm now going to pick up this transmitting antenna, because I know that cable's got to be coming out of that conduit into the ground and heading one direction. So we're going to walk a circle around that conduit or around that pole, always keeping the end of that antenna pointing at the pole. So as I try to keep this 30-foot range, I'm going to walk pointing at the conduit. Notice about right here, I'm starting to pick up tone on my receiver. And I'm about 3 feet off of the edge of this asphalt right here. So I make a visual mark that I'm about 3 feet off, and I keep right on going through. And over here, oh, I must be probably 6-7 feet from the asphalt where I actually lose the tone. So I'm going to guess about halfway between, set the transmitting antenna pointing at the conduit still, and then I'm going to walk back and I'm going to turn the receiver down now, because this is too wide an area to actually get the absolute route of the cable. So I'm going to go back and turn the receiver down to where I can just barely pick it up here. All right, I've turned that receiver down now to where I can just barely pick up the sound. And notice now that if I go this way, I've lost it. I'm starting to pick just about a foot inside the grass, and there I've dropped it. By turning that down, I've got an absolute mark now of the route of that cable, because anywhere else the receiver can't pick it up. Notice also that we talked about if we turn the antenna sideways, we've lost the tone. And that's because this radio wave is linking this conductor twice that's running this direction. So I'm over it, and I'm in line with it right there. Now, I could pick the receiver up and move this way maybe 10 feet, locating the route of the cable. Then I could actually move the transmitting antenna to that spot, and then I could come back to this point with the receiver and trace on down the line. Because at all times, we must be at least 20 feet on low power from this antenna with that receiver, or we're just going to pick up the antenna. Let's go back in the classroom now, and we'll continue on. In summing up this portion of the tape, which we call inductive tracing, the key points that you should understand is something about the transmitting antenna that you're using, regardless of how it's packaged, whether the antenna is inside of an enclosure or it's an open picture frame, as we have here with the Aqua-Tronics Model A7. You need to visualize how that line or how that energy band is going to leave the transmitter and get into the ground, so that you know the direction of the antenna when you set it on a line. And why? You need to know the distance that you're setting the transmitting antenna from your receiver when you're in the field, because if you get too close to your transmitting antenna, with the Aqua-Tronics is 20 feet. If you get too close, you're going to flood your receiver with signal and not find the line that you're looking for. And lastly, on inductive tracing, you need to know how to locate a utility when you have no physical access to it for a direct or a conductive, inductive coupler type trace. You can do this with inductive as we've shown here. This is where you carry your transmitter and set your receiver down. When you feel comfortable with that method of locating, then we can proceed into the remaining portion of the tapes.